Dividing decimals by whole numbers is very similar to dividing just a whole number by a whole number, except there's one little change. But first, let's kind of review some vocabulary. So if you have a division problem, say you have 12 divided by 2, when you're reading this equation from left to right, the first number is called the dividend. This is the number that you are putting an end to. You are breaking it down into separate groups. This one goes, and I'm going to use house as the term inside the house. So when you're setting up your division problem, the dividend is the number that is inside of the division bracket. The second number in the equation is called the divisor. This is the number of groups that we are making. And this is the number that goes outside of that house, outside of that division bracket. When you begin your division, it's super important that you always make sure that you move the decimal point that is inside of the house up into your quotient immediately before you start dividing. Neatness is really going to matter when it comes to this type of division. You're going to have to make sure that you are keeping things lined up in the right spot. So let's look at this problem. So this is my dividend. So 9.92, of course, is going inside the division bracket, and 8 is going outside. I'm first going to start with this decimal, and I'm going to bring it straight up into my quotient. So that way it is right up on top of that division bracket. Then I'm going to divide just as I would if it's not there. So I'll start with this 9. 9 divided by 8, of course, is 1. 1 times 8 is 8. Subtract and you have 1 left over. So then you bring down your 9. 19 divided by 8 is 2. When I write this 2, though, I'm going to write it directly on top of the number that I just brought down. Every digit in my dividend is going to have something written above it this way. 2 times 8 is 16. Subtract and we have 3. So then I'm going to bring down a 2. 32 divided by 8 is 4. 4 times 8 is 32. Subtract and we're left with nothing. So we end up with 1 24 hundredths as our answer. Now, of course, problems aren't always going to be as straightforward. There are times that you are going to have to annex zeros. For example, let's look at this problem. Again, I'm going to bring that decimal point straight up into the problem. And I'm going to start with 8. 8 divided by 12 would be 0. 0 times 12 is 0. I have 8 left over. And then I'm going to bring down my 5. 85 divided by 12 is 7. Again, it goes right above that 5. You always write your number in your quotient above the number that you just brought down or the number that you just divided. It's like the 8, we put the 0 above. 7 times 12 is 84. Subtract and we have 1. And then we're going to bring down our 8. 18 divided by 12 is 1. 1 times 12 is 12. And we still have 6 left over. So I'm going to have to annex a 0, meaning I'm going to add a 0 to the end of this problem. It does not change the value. And I'm going to bring it down. Then I have 60 divided by 12, which is 5. 5 times 12 is 60. Subtract and I have nothing left over. So I end up with 0.715 as my answer. One more situation that you can find yourself into. Let's set this problem up. I'm going to bring that decimal point straight up. 7 divided by 3 would be, of course, 2. 2 times 3 is 6 with 1 left over. So I'm going to bring down my 5 and I have 15. 15 divided by 3 is 5. Nothing is left. I got to bring down this 4. 4 divided by 3 would be 1. 4 minus 3 is 1. So I'm going to add a 0 and bring it down. 10 divided by 3 would be 3. And look what happens here. I'm going to subtract and I'm going to get a 1 again. So what's going to happen is I'm going to have this constant recycling of this part of my division. So knowing that, I know that that 3 is going to repeat. So I'm going to write my repetant up above it. So I get 2.513 repeating. That repetant is just above the 3 because I know that that 3 is the only part that repeats over and over and over again.